Koto, welcome to this final video for this section of acids and bases where we look at how to balance equations. So balancing equations. So with chemistry, what we like to do is write using symbols a formula that represents what's going on in reality. So in this case, we've got HCl, which is acid. So that's in the cupboard in the science rooms is some hydrochloric acid. Mg represents magnesium. So magnesium metal's got that shiny surface. If we react these two together, what we're going to get is some fizzing that occurs. So if we were to put hydrochloric acid in a test tube, put some silver magnesium into the test tube, there would be some fizzing that occurs, and then eventually that magnesium metal would disappear. You would no longer see that, and the bubbling would stop. So what's actually happening in that reaction is that we're getting something called magnesium chloride. Now this is, you'll know this is an ionic compound, having done the last couple of videos. So we've got a magnesium ion and a chloride ion there, two chloride ions. And the bubbling that occurs in this reaction produces hydrogen. So this is a chemical formula that is just there to represent what's happening in reality. So we can't change too much about this because that would be changing what's going on in reality. So we need to keep this pretty much the same. We can't change that there's hydrogen gas. We can't change that there's magnesium chloride. We can't change that there's magnesium metal, and we can't change that there's hydrochloric acid there. But what we do need to make sure is that we've got the same number of atoms on the left-hand side of the equation as we do on the right-hand side of the equation. So you may have done the experiments where we were doing experiments and weighing or finding the mass of all of the reactants. So we're putting things on the scales and finding the mass of the reactants. We were then doing a chemical reaction and then finding the mass of the products. And what we found out is that the mass doesn't change in a chemical reaction even though the atoms switch around. So the impact that has in reality is that we have to have the same number of atoms on this side of the equation as we do on this side of the equation. So here we've got, if I just draw out these compounds, we've got H, so I'm going to draw a hydrogen atom, just like that. I'm not going to do the charges on them at this stage, I'm just drawing the atoms with circles there. We've got a magnesium atom, which I'll just draw it as a circle there. Then we've got a magnesium and two chlorides. Like I say, I'm not doing the charges, this is just quick and simple. And H, hydrogen gas, which is just the flammable stuff that is just two hydrogen atoms bonded together. So in this case, we've got one hydrogen atom there that you can see, which is represented by the HCl. We've actually got two hydrogen atoms over on this side of the equation though. So if this reaction was to represent reality, then we would end up, by doing this reaction, we would be creating an extra hydrogen atom. And it's the same with the chlorine ions, or the chlorine atoms as well. We've got one chlorine atom there and two chlorine atoms on this side. So our products would end up being much heavier than our reactants. And so if this reaction was taking place, we'd actually end up with more and more and more stuff, which is impossible. So what we need to do for this reaction to truly represent reality is that we need to have the same number of atoms on the left-hand side of the equation as we do on the right-hand side of the equation. And so the way that I work this out is that what we can do, well, one thing that I'll do is we'll count up all of the atoms. So the number of hydrogens on this side of the equation is 2. Is 1. And on this side of the equation, we've got 2 hydrogen atoms. So we need to somehow make 2 hydrogen atoms on this side of the equation. The number of chlorine atoms that we have on this side is, wow, I just made a shape. We've got 1 chlorine atom there, and then on this side we've got 2, so we need to sort that out. Magnesium though, we've got 1 on this side of the equation and 1 on that side of the equation. So the magnesium part of it is fine. So what we can do to balance this equation is add more than one of these molecules. So what we could do, for example, and this just happens to work out, is that we could add another hydrogen chloride, so another Sorry, those aren't supposed to be bonded together. This is a separate hydrogen chloride. We could add another one of those, and then we've now actually we've now got 2 hydrogens there, equals 2, and we've got 2 chlorines, equals 2. So we've actually now got the same number of atoms, and this is just my working down the bottom, on both sides of the equation. We've got 2 hydrogens, 2 hydrogens, 2 chlorines, and 1 magnesium, 1 magnesium. So what's happening in reality is that we've got 2 hydrochloric acid particles reacting with 1 magnesium particle to form 1 magnesium chloride and 1 hydrogen, and that can happen when we end up with the same number of atoms on both sides, and so we're not creating anything, we're not doing anything that's impossible. So the next question is, how do we represent what's going on in reality using our chemical formula that as chemists we like to use to represent what's going on? So we can, do you think, put a 2 there and a 2 there? The answer to that is no, because that would be saying that we're changing what's actually going on. So this hydrogen chloride is bonded together, that hydrogen chloride is bonded together. What we would be saying with those 2's is that we've got 2 hydrogens and 2 chlorines all bonded together in what kind of has ended up looking like what I've actually drawn. So what we need to do is, when we're balancing equations, the only place that we can add numbers is behind the whole chemical that we're talking about. So if we put a big number there, then that tells us that we've got more than one of those things. So if I put a 2 there, then that is saying, using this chemical formula, that we've got 2 hydrochloric acid particles. Okay, we'll move on to another example. So here we've got methane plus oxygen goes into carbon dioxide and water. So that is the combustion of gas, of flammable gas. So we've got, in this case, I'm going to draw it out the same way that I did last time. So we've got a carbon here and 4 hydrogens surrounding that carbon. 1, 2, 3, 4. And we've got 2 oxygens. So that's a little trickier to draw. So 2 oxygens there. And that is going into a carbon dioxide. So we've got a carbon bonded to 2 oxygens. And we've got a water. So 1 oxygen atom bonded to 2 hydrogen atoms. So underneath again, I will do the working that I had before. So I'll show that with the hydrogens, we've got 1, 2, 3, 4 on this side, but we've only got 2 on that side, so that's a problem. We've got 1, 2, 3 oxygens on this side of the equation over here, but we've only got 2 on this side of the equation over there. Tricky, tricky, tricky. And carbon, we're all good. We've got 1 carbon there and 1 carbon there, so that's fine. 1 and 1. So what do we need to do to make the atoms on this side equal to the atoms on this side? Because if this reaction took place, we'd kind of be gaining an oxygen and losing a hydrogen, and that's not what happens in reality, because we need to have the same number of atoms on the left-hand side as we do on the right-hand side. So to change that, what we could do is, if we want to times this by 2, that would give us 4 hydrogens on that side. And in practice, what that means is that we're going to add another water molecule. So I'm going to add another water molecule here. So what's actually happening is that we're producing 2 water molecules, not 1. And so that will mean that we've now got 3 plus 1 oxygen atoms as well, because we've got 1, 2, 3, 4 as part of this. So we've got 4 oxygens and 4 hydrogens. So what I need to do with our formula is represent what I've just shown with those 2 water molecules, and I'm going to put a 2 there to say that we've got 2 water molecules. And now we've come closer to balancing the equation. We've got 4 hydrogens and 4 hydrogens, but these oxygens still aren't right. So what we can do to balance that is then add another oxygen molecule, another O2 molecule. So we'll put another one there, then we're actually going to have 2 times 2, which is going to be 4 oxygens. So that will be balanced there, so that's all fine. So we've done it perfect. But we just need to show in our formula that we've actually got 2 of those. So these are the things that we need to do to balance equations. We balance equations to show what's actually happening in reality because if we had an unbalanced reaction, that would be saying that we're actually just producing things that we are not. So in chemistry, we try and use these formula to represent what's going on in reality, and by balancing them, that is the best way of doing it. It's just a bit of a trick to get used to it, and understanding where we need to put the numbers to represent what's happening in reality. So give this a go. This, in terms of NCEA, is worth excellence. So if you can get there, that's fantastic. If you can't, there's plenty of opportunity to get achieved in merit without it. All the best. Thanks very much for watching. Like and subscribe for more chemistry and science videos.